Okay. Good afternoon, everyone. My name is Mark Durina. I'm going to present today, moving a bit from the awesome use cases that everyone is exposing today, some of the programmatic tools, in this case, that we developed in the lab, in this case called plexosdb. The lead researcher for this project was my colleague, Pedro Sanchez. We are the only ones currently providing some maintenance and even more further development to this one. Hopefully, it will bring a lot of value to any of the workflows you are developing right now. So following up to that, the agenda for today will be, I'm going to talk about what plexosdb currently is and how it works, describing some of the core capabilities in architecture. Then we're going to move to some performance highlights for some of the big cases we've worked with, in this case, the Eastern interconnection, with moreover that more than 500,000 properties, memberships, and so on. So we want to accelerate that process for a wide range of scenarios, weather years, and all that. And we try to come up with a measurement to see how well it works under that stress. And then, of course, we're not going to miss about talking about the AI for a bit. So we're going to describe a bit of the MCP server and agentic integration to our tools. Then we're going to describe some of the code workflow patterns and use cases we currently use across the lab, and some external requests we receive for developing this kind of workflows. And then some closing remarks and future work regarding this tool. So across many of the works that we do at the lab, it comes to us many questions. Many questions arises throughout our developments, and how can we better integrate tools into already licensed software, like PLEXOS in this case? How can we better scale, improve our workflows? So the plexosdb idea is the convergence of all those ideas that we put together. So in this case, we start with a minimal and performant high fidelity model from the PLEXOS schema, and put everything, all that, into an SQLite database. So every enum, every class enum, every collection, every small checkbox you have in your PLEXOS system, you will see it already in the SQLite database that is working as the architecture backend right now. Okay, so we're going to describe now how it basically works, so the whole 5 steps. Right now, we just start with a load model state, where we have a specific model you want to load, being Konos, the Eastern interconnection web, or whatever you're using. And then from that, even if you want to create your own, it works the same way. Then try to come up with all this high-fidelity model from PLEXOS to SQLite, which with the SQLite manager classes we have inside the tool. All of that is, of course, open source, so you can check it out for all of the structure we follow to construct this programmatic way of doing PLEXOS runs. Then once we have the SQLite manager database as a relational table, of course, we call the whole parser, the XML parsers, that will allow us to have the exact high-fidelity PLEXOS system into our SQLite database. So we use a specific disabling foreign keys for inserting all the rows. Otherwise, we will have those check-ins, and at the end, we will have a wrong database call. And then we just disable it, then enable it, and we have a high-fidelity SQLite database of our PLEXOS model. Then calling the model configurations in this case. So for every SQLite call we have, then we add a specific object, membership, records, explicit validation of classes, collections, and insert properties with metadata scenario, in this case for all of the properties, each component, the PLEXOS like generator, node, storage, or whatever we have there, it is. Then we query and inspect model states. So we check for every component inside your PLEXOS database. In this case now, an SQLite database. Perform continuous checks, and that depends on your preference choice in this case. And last one, the export model state, which we provide a round trip between parsing the system and then exporting it as it is exactly with all the modifications you've made. And describing a bit of the core capabilities in architecture, the providing of the SQLite backend, it's basically for the high-level systems that we've worked with, like the Eastern interconnections in this case, works pretty much fast, so we do not move from that. The SQLite works pretty much as we wanted to work. We have a type domain API, like for every component in PLEXOS, like as I was mentioning before, the enum, the collection, or whatever component you have inside is already mapped in the SQLite database. We can build high-level pipelines, like if you build for your specific generator in many scenario instances. You can perform bulk operations like 100,000 memberships and properties and do it with fast and scalable pipelines in your workflows. We have the enum-driven mapping as well, which is basically what I was mentioning before. Like it is every SQLite component inside our database is mapped with a respective PLEXOS schema that we already have in our model. And then the round trip, of course, trying to serialize back from a SQLite database to a high-fidelity XML at the end so that any of the work on the code that I'm going to show later is not lost at all. Now, regarding the benchmark operations, we tested this out, as I was mentioning, with the Eastern interconnection system, which is about like more than 500,000 memberships and more than 1 million properties, and measure all of them like as a benchmarking system, since all of the other ones will work correctly after this one, after testing in this one. So for working the pipelines on the Eastern interconnection, basically, will take up to 5 minutes to just run the whole bunch of scenarios we have showing in there. And the same if we provide the approach for the chunk sizes that every property has for processing those elements, we will have the differences in the speed that we can actually get out of that. Now, talking a bit about AI in this case, as the fever of this kind of agents has come up to us, maybe the MCP server comes up a great help in case you don't have experience with working with SQLite or working with Python specifically, so that the MCP server, as you can see it all from here, I'm just going to explain it very briefly. It is like a bridge between your agent, the agent you're using right now, and our package. So in the package, in our server ourselves, we just put the core capabilities that the package has, and then you will be able to use it through the agent. And together with the MCP server, we have the skills methodology for better agentic integration, where we will reduce token utilization, but providing these core capabilities. So your agent will just go through it, and whatever questions you have, like how much nuclear do I get from a specific node, how or why are the flows too high on a specific interface, the agent will automatically execute the query, and you will get out the results that you really want out of that. Of course, you can test it out, but yeah, this will be much faster in case you do not want to do it yourself by hand, like programmatically writing the code, and you can save more time on that. So since the tool came from 2024, right now many people are not like writing their own pipelines. They just leave the agent to do it by itself, so that you can save other type of analysis. Now I'm going to go and explain a few code patterns in use cases that we, as a simplified way to explain how this is working right now. So we start importing the necessary libraries that we're going to use. Then we can load the system, an energy model we already have, which is the default XML, or create a schema that will automatically load a system object, and then will perform you will perform everything you need to do inside that, like adding objects, including the categories, then linking both objects by the memberships. That's how it works inside PLEXOS. And then for that specific node or generator you have, you will add the property, whatever property you want to have. And then even if you have a solar or a wind generator, you can attach the metadata, the CSV data that is in the folder, attach it to the specific property. And of course, you want to work with bands or with tags or whatever other capability PLEXOS has inside. You can call it with the add and band, which is the default for every other property or method we want to do it. Of course, you can look it up on the documentation. OK, for running scenario expansion with bool property inserts, in this case, we present a lot of property inserts for all the object generators we have. So if you have a lot of records to add to your existing model or creating a new one, you can do it with add properties from records and export the XML after that, if that is just intended workflow. So for large system, we've done the benchmarks as well, and it works pretty much fast. In case of the bulk relation creation, it is the same thing. It's just that right now we work with memberships. So you can do the same approach inside the list or a dictionary. In this case, for adding every membership, link it to the necessary region and object you just created, and specify the chunk size in case what you want to achieve is a speed in case of large systems, so that you can tell the database the chunk size that you want to process all the records. Now, if you're a bit of a geek on SQL interaction, you can do pretty much advanced queries, because as I was mentioning, so imagine the whole PLEXOS ecosystem in the PLEXOS desktop that I'm pretty sure you know how to use. All of that is mapped into a SQLite database, and then you can just query directly, doing whatever query you want to do for extracting the memberships, properties, or whatever other transactions you want to use. So for every method we have implemented, the transaction works pretty much for each of them, so that we can, for every operation we do, the whole transaction holds all of that for the open and close, and we can do much faster operations with that. I'm going to go a bit to describe the use cases that we've been working this for. In this case, for the system data on the TVA system, we previously worked with a reads tool, which is a specific tool for capacity expansion models. The workflow particularly is useful because for the capacity expansion model, we want to, as a national lab, we use many tools, and all these tools need to be interconnected. We want to have a seamless integration. So for the capacity expansion model, we translate all the reads results into a corresponding PLEXOS system. And for that, we did PLEXOS at the background, like for a the high fidelity copy of the capacity expansion model to a production cast model, in this case, using the R2X tool. So it comes in handy and pretty useful when you want to run many iterations of changes in your database. So you have a wide range of scenarios and a wide range of weather years, and want to specifically target a generator, transmission line, interface, or whatever you want to do in each of them. You can do it programmatically pretty much fast with a few lines of code and have a system faster. So since this has been benchmarked for the Eastern interconnections, it works much faster on small systems. So in case of manipulating large data sets, we've overcome this kind of barrier where we will take hours or even days sometimes to live running an Eastern interconnection system. And since right now we can perform this faster on the SQLite database, we can have many Eastern interconnection scenarios, XML systems exported with different capabilities, all of that working in this case, because sometimes if you want to export an Eastern interconnection system into the PLEXOS desktop, it kind of becomes a bit like laggy or tricky to manipulate there. So if you want to run this for many scenarios or do different changes, this comes in handy for you to work it on. OK, some closing remarks on this. This is by no way a way to replace what you already have, but it works complementarily to all the existing infrastructure you already have. It is just a way to improve, accelerate your pipelines, your workflows, to having a better structure now with the plexosdb capabilities. Right now, we're providing a lot of backwards compatibility. So we work for version 9, 10, and currently we're working in version 11 because, as you are aware, for each jump of version, we have different enums, different collections, and different capabilities. So we need to keep up with those changes in Plexos itself so that your workflow is not ruined. A last remark will be that some of the changes we've made right now is being really strongly in the improved documentation because we know that people have doubts right now on how to better introduce this in your workflows, in your pipelines. So we do have improved documentation on that, on the site that you have. And working externally as well, not just internally in the laboratory, we have many requests from people that knows how to improve this, or maybe in their workflows this doesn't work well because we have methods that are not implemented yet. So we receive the request, implement the methods for them, and they can work seamlessly on their side for this one. So thank you. I will see questions. Oh, I think.
Thank you for the wonderful presentation. I just had a few questions to better understand the benefits of plexosdb over the native API capability at the moment and to understand the motivations of what this tool provides. So outside of the ability of adding and querying, was the main motivation behind plexosdb to have a tool that's faster and more efficient? And if so, could you comment on the potential benchmarking difference between the two and the advantages of plexosdb over the native capability?
So you mean with the native capability, the PLEXOS API, right?
Yes.
So initially, we've tried to work with all those capabilities. It's just that when this first came out, the PLEXOS API, it was hard. It was having some trouble with installations. And at the time, we had some particularly advancements on working on our side on developing new tools. So this was just with the purpose of being like open source, work on our side, and develop a tool that will not bring that much trouble. It just hit a UBPP install and have all that potential so that you can run your model in huge databases, running many scenarios, modifying the database as whatever you want it to be without having these lagging features that normally a capability like the desktop has right now. So you can move all your workflows for working on the UI to do it yourself programmatically. So that's why the title normally specifies that it will be a programmatical tool for Plexos model construction. So everything is already mapped there, and you can work yourself there. But in any way, it will work like in the Plexos API itself, because you can do simulations run there automatically, and this is not like a link API for the Plexos itself. It is a separate tool that works complementarily for your own pipelines.
Thank
you. Thank you again for presentation. So one quick initial question is if it's restricted to SQLite, or if that's kind of interchangeable with other SQL tools. And then the other one is if you can comment a little bit in terms of whether this tool helps bring in the CSV files that Plexos uses, or it just keeps record of the data file connection to it, sort of the path of the CSV files, or does it load the full CSV files into the SQL database? Is that clear?
Okay. Yeah. Thanks for the question. First of all, I just want to start from that part. Right now, yeah, it is a full integration. So it comes from the specific CS file you provide from there. So it should live into a data files or whatever code that has data in it, as Plexos already is accepting it. So if you have everything stored inside a data folder, it will automatically recognize it and load it into your SQLite system. So so I didn't show this one, but let me just show you real quick what I mean. So in here, you will see that you have a T data, T membership, T object. So there is a T underscore default for every enum, collection, membership, and object. So in the T data, we will have every CSV, every TXT, or whatever file you are attaching to it. So it will live inside the database. And when you exported it back, it will automatically recognize it as a data folder, and PLEXOS will catch that and add it to you. I'm sorry, what is the first question? I just...
No, it's okay. And the first one was if it's restricted somehow to just be SQLite,
oh, okay,
or
yeah,
do you have, or if it's capable of using other SQL engines.
So as of now, the biggest system that we've been working with and doing benchmarking is the Eastern interconnection and the Conus one, integrating all those separated systems to see how it behaves. And we found out that the SQLite itself behaves pretty much well for those enormous systems that I'm not really sure if everyone is working with the Eastern interconnection, but if you work with the small systems, I think SQLite is more than enough for that. But if you want to use any connection to PostgreSQL or MySQL itself, it will seamlessly, I think, work. We haven't tried it because we didn't see the need to use it right now, but yeah.
Okay, thanks.
Thank you so much, and definitely what you presented sounds very familiar to me, because I truly see the value of using the plexosdb and how we can, build so much automation leveraging the plexosdb. So, have you thought about exploring file parquet? I don't know if you've heard of this, new feature, because I think it can truly play a significant change with the big data, like if you have big data that is coming out of PLEXOS. So have you ever thought, or do you have any examples about leveraging file parquet?
Yeah, we have some of these requests where you normally have in this case, for the Eastern interconnection, again, I'm sorry, I'm going to take this one because this is the benchmark for us. We have a huge Parquet and H5 files. I'm sure you heard of H5 files, where you store a large amount of data there, and it becomes compressed, and you can share it like millions of CSVs inside this H5 file to do the interconnection better and store better, or time series, or whatever huge data we have. Right now, we are currently mapping that and integrating it seamlessly on the tool. It is not fully tested. That was I didn't touch it. So. But yeah.
Okay, good job anyways. I would definitely recommend using the file parquet.
Okay, yeah, for sure. And with that request, I will definitely implement it. Thank you.
You mentioned sort of continuously updating the library every time like a new version of PLEXOS is released. What is the typical time frame on that? Like how soon after a new version?
Yeah, it will take just a couple of weeks because we do kind of back testing with the version 9, version 10, and right now version 11. So there are a lot of features, a lot of enums, a lot of collections, a lot of T configuration files that the new versions of PLEXOS is providing. So we need to make sure that we are correctly mapping that, and we make for sure that for version 9, for version 10, that is implemented. But right now for version 11, that I think there are many of the things that are missing right now that we haven't tested. So that's why we are just still working on that one and provide full feature integration with the 9 and 10 versions.
Okay, and so if there are like updates to properties or capabilities within PLEXOS, those would be captured?
Yeah, so if I remember correctly, the enums basically have increased to 10, collections have increased to 300, and property has increased to 700 new properties for all the components. So we need to map exactly with all of them to provide them on the high-level mapping that we have in the SQLite database to be sure. So yeah.
And then one other question. So with this library, are there any capabilities on sort of the output side with results or solution files, or is this strictly just for creating new databases?
Right now, everything you can do on the SQLite database is outputted as an XML file together with all the T data. That means the TXT or the CSV or H5 files you provided inside that. but currently that's the only round trip between inputs and outputs that we specifically provide. So yeah, under any of your requests, if any on the repository, we can catch that and do it as a task to provide better integration as this keeps updating with any requests we have externally.
Great, thank you so much.